In n independent fair coin flips, what is the probability of having k changeovers? A changeover event is defined by a coin flip having a different outcome than the previous. So for example, in this case, we are going to have 3 changeovers. So from going to head to tail, that's 1 changeover. And then tail to head is another changeover. And then head to tail is another changeover. So normally this is quite a difficult problem for a biased coin with probability p. But with probability 1/2, there's actually a trick to this question. So let's re-encode the event. So let's let C be the event of a changeover. And then we'll let C bar be the event of basically staying the same, no changeover. So if we encode the above example, it's basically going to be, we always start with H, so there's can never be a change event, over event on the very first step, but the second H will basically be a no change, third H be a no change, and when the tail happens, that's a changeover event. And again, no change, a change, and a change. So notice there are a total of 8 flips here. Once we map it to the changeover events, there are only 7. So it's always 1 less than the number of flips if we encode it this way. So now let's think about the events. What's the probability of getting a changeover? Since it's always a fair coin flip, the probability is always 1/2. And same thing for probability of a event of getting the same flips, again, no changeover. It's also 1/2. So now we can apply the binomial distribution. Basically, the question is, if we are given n flips and k changeovers, what is the probability of that? So we know that if we encode the events from flips to changeover events, we will have basically a bunch of change and no change events, and the size of them is n-1, and we want k of them to be changeover events in this n-1 events. Basically, that will be n-1 choose k, and since the probability of a changeover and no changeover events are always 1/2, basically 1/2 to the n-1. So that's it.